The Pacific Island nations lack the adequate infrastructure to protect natural water sources from contamination, risking the proliferation of waterborne diseases. Between 2009 to 2011, an uncontrollable cholera outbreak spread across Papua New Guinea, resulting in 15,000 infections and over 500 deaths. Increased extreme weather events threaten the supply of safe drinking water, further exposing Pacific Island nations. In order to achieve Sustainable Development Goal number 6, populations must have confidence in the safety of their water supply. In order for Pacific Islanders to access guaranteed, safe water sources, routine monitoring and testing must be done for contamination and disease. However, routine laboratory-grade testing of every water source is expensive and impractical for developing nations. While community feedback is resourceful, contamination of waterborne diseases, such as cholera, can be difficult to notice until after an outbreak has occurred. Our solution to this issue is a tap nozzle that can be distributed to households and businesses. It's composed of a nozzle attachment with a built-in sediment filter to remove particulates. This nozzle also has a reaction chamber which contains polyclonal antibodies and a colorimetric dye such as tetramethylbenzene. This enables real-time detection of biological contaminants. Users observe changes in the dye's colour to identify potential contamination of their water. Upon noticing a change, users can scan the attached QR code to report the data. All user-reported data is sent to a centralised system which logs and displays points of concern and assists in the development of a response. When addressers first receive their nozzle, they will install it and scan the QR code to set it up. They log their home address and what room the nozzle is in, similar to a Google Home. Next, water passes through the nozzle where large particulates that could damage and interfere with the reaction chamber are removed, and the contaminated water reacts with the polyclonal antibodies and the TMB indicator. The dye then changes colour, instantly making visible that a contamination is present in the water source. The user observes the colour change and reports the contamination via the mobile app by scanning the QR code on the nozzle. The data is published on the app and made visible to everyone, including local health authorities, doctors, and other residents. This data is also stored and triaged based on a prioritative AI system, which assists in the allocation of resources and response based on that data. Mobile response teams would then investigate sources of contamination which are reported. They collect water samples to complete more comprehensive water testing and ensure the addresses' nozzles are refilled and working correctly. After this, further action is determined based on the results of the comprehensive water testing. For example, clusters of cholera outbreaks may indicate contamination issues at the water source which supplies all those infected, which can then be addressed. The nozzle itself would be made out of polyethylene terephthalate, either mass-produced and brought into the site of concern, or 3D printed locally using PET filaments. The sediment filter would screw in with a thread on the nozzle, making it easily replaceable. The thread itself would be standardised for the location, but other options may have to be produced to account for all types of water outlets. The refillable reaction chamber makes the nozzle itself a permanent fixture, only requiring refilling of the antibodies and dye, routinely performed by the mobile response teams. Our solution has a range of benefits which make it applicable for a developing nation. It's cost-effective, which means it's designed to be low cost for widespread community adoption. It engages local communities in monitoring their own water quality, empowering them to do their part. It uses real-time reporting to ensure immediate awareness and response to water quality issues, and it also uses enhanced geospatial mapping, where data integration allows for detailed mapping of water quality across regions. This data can be used in predictive analytics to forecast potential water quality issues. Data is recorded from nozzle testing and integrated into geospatial information systems to identify high-risk clusters of infection. Such information enables health authorities to redirect testing, quarantine, and alternative water sources towards high-risk areas. This information also enables authorities to identify and shut down and treat contaminated water sources. The rollout of these nozzles would be funded by a government and not-for-profit partnership, ensuring that there is no cost to the user. This would also ensure stability, scalability, and effective community implementation and education. The reporting app encourages community engagement through self-reporting features, actively involving them in their own well-being. The app also is a hub for educational resources on safe water practices, ensuring a wealth of knowledge and expertise is at the fingertips of the users. Our mobile app provides a user-friendly interface for both users and health officials. The dashboard displays real-time health metrics and trends, facilitating efficient monitoring and response.